All right, hello everyone. This is another question from homework 40. I'm looking at problem 2, part 3. So this is the question that is on the back in the lower left-hand corner. So part 3, question 2. All right, so here, first thing that I'm noting by looking at my picture, O is the center, right? O is the center right there. So I'm making note of that. And I know that any radius, it's got to match any other radius. So I can put tick marks here if that is helpful. So again, my radii are going to be congruent. Any radius will be equivalent to any other radius, whatever its measure is. And we know that the segments themselves, they're going to be congruent. All right, so then if I'm looking for a starting point, it might be this 35-degree inscribed angle. So if I know that this inscribed angle right here is 35, if I move out to its intercepted arc, I double it, and I get a 70-degree right here. Okay, one other thing that I can note really quickly is, again, I have an isosceles triangle. We had lots of isosceles triangles in this problem set. So I have base angles here and here that have to be the same, so 35 degrees. Remember, with any isosceles triangle, if I have two congruent legs, those base angles, the angles opposite those legs, they have to be congruent too. So now I just need the vertex angle right here, right, that vertex angle. So if these are both 35, that sums to 70. So I'm missing 110 to take me back to 180 total. And once I have that 110, I got a linear pair right here at 70, right? That makes sense because it's a central angle. There's my vertex, it's the center, and this is its intercepted arc right here. Okay, linear pair 110, and then over here got to be 70 as well. These are vertical angles. Okay, so now a couple more places to fill in. So if this is 70 and I have another isosceles triangle, these two angles have to be the same. They're both base angles. So if I take the remaining 110, split it two ways, I get 55 degrees here and here. Okay, I also know that if this is a central angle, this is its intercepted arc. So I know that this has to be 110 total. So if I take my 110 and subtract 42, I'm left with 68 degrees right here. Okay, I'm going to keep working my way around. If this is a central angle, then its intercepted arc would be 70 degrees. If this is a central angle, its intercepted arc is 110 degrees. Okay, if I move out to where, say I look at where the T is. Okay, so with T, if I trace it up like this, its intercepted arc is 112. So if I take that 112 and I split it two ways, I get 56 right here for that angle measure. If I go to where R is, so here's R, and I trace here that ray and this ray like that, I can see that altogether the intercepted arcs have to be 70 plus 110 plus 70. And then I have to split that two ways. So here we go. I'm looking at, again, from here to here, that was 250, and then I divide that by 2, and I get 125 for this inscribed angle right there. And then the last one that I want is this one right here. So if I trace down and over like that, so right here I have 68 plus 70, and then I have to divide that by 2 as well. So that gets me 69 degrees right here. And let's say that I just double check that because I see that this is a quadrilateral. I want to make sure that it sums to 360. So if I take a moment just to double check my work, 69 plus 125 plus 56 plus 110, you can see, oh, beautiful, it sums to 360. Okay, so now just filling in those missing measures. AY right here is 70. That's a minor arc, 70 degrees. AOY, that central angle, also 70 degrees. Okay, YOS right there is 110 degrees. Minor arc ST, S to T right here, also 70, lots of 70s in this problem. RT, minor arc right here is 68 degrees. and then ART, that angle is 125 degrees. All right, there we go. Keep the questions coming. Hope you guys are having a good day.